To start our final review, we'll look back at Unit 1 where we learned all about solving different kinds of triangles. Our first question here is asking us how many triangles can be determined, and they're giving us two sides and an angle. So let's start with a picture to get an idea of what this triangle might look like. So one of the angles, they called it A, is 40 degrees. Across from that angle is side A, that is 3. And then one of the other sides somewhere in the triangle is 2. So based on our drawing, it looks like we have an angle in the side across from it, so we can use law of sines, which is our way of determining a number of triangles. So if we set up the law of sines, we've got sine of 40 degrees divided by 3 equal to the sine of some angle, which the angle missing here would be B according to the side that they gave us, and that would be over 2. So if we solve for sine of B, that means we're going to take 2 times the sine of 40 degrees divided by 3, which is approximately 0.4285. So B, that angle would be about 25.4 degrees. So that tells us, in this case, since we didn't get an error, that there is at least one triangle. But remember, with law of sines, we also have to be checking to see if there's a possibility for a second triangle. So to do that, we're going to find the alternate angle B, B prime, and to find that, we find the supplement of the angle that we just found. So the supplement of 24 or 25.4 is 154.6 degrees. And now what we're basically saying is if we take that angle plus the angle that's in the original triangle, the 40 degrees, and add those up, that's going to get us 194.6 degrees in the potential second triangle, which obviously we know that a triangle can't be more than 180 degrees. So since that's greater than 180, there's only one triangle in this case. Now for question 2. Again, they're giving us some random triangle ABC. They're giving us the 3 sides. So I could draw this out just so I have an idea of what it potentially could look like. We've got a short side 9. We've got another side. This isn't obviously drawn to scale. That's 40. And then a large side that's 45. And we're supposed to find the measure of angle A, which in this triangle would be up here. Since they gave us 3 sides, we are looking at the law of cosines, and we're solving for angle A, so we're going to take cosine of angle A and set it equal to, and in this case you might have to manipulate a formula in your formula sheet, but the correct setup should be 40 squared plus 9 squared minus 45 squared, all over 2 times 40 times 9. Now, be careful in inputting all that in your calculator. Double check that you're using parentheses correctly. We should get negative 0.4778 approximately. And then if we take the inverse, cosine inverse, that means that our angle A is 118.54 degrees. But if you notice here, they asked us to go to degrees, minutes, seconds right here. So that means that we've got to use that DMS function on our calculator. And if we change it to just degrees and minutes they're asking for, that's going to be 118 degrees and 32 minutes. Question 3. Again, they're talking about a random triangle ABC. Looking before I draw it here, we know it's going to be obtuse because there's a 100-degree angle. So we'll make that the 100 degrees. We've got some angle A that's 45. And then they gave us side A, so across from the 45 is 6. We have to find the length of side B. So let me add in the missing pieces here. Across from the 100-degree angle would be side C if we had to find it, which means that this side over here would be side B. And then this is angle B, which according to what they gave us, we can find right away. It's just going to be 35 degrees to finish out the triangle. So now to find the length of side B, we can simply use a law of sines because we have this angle and it's across, and then we've got the angle that we just found, 35 degrees, across from the side that's missing. So if we set that up, we've got sine of 45 degrees over 6 equal to sine of 35 degrees over this missing side we're trying to find, B. So to solve for B, you can do this directly in your calculator, but to check your input, we take 6 times the sine of 35 divided by the sine of 45. And that just gives us about 4.87, and I'm going to put a U there for units. Question 4 brings back a word problem. Now, recall that with word problems, there's multiple ways of solving this. The important thing is to get the setup and the structure of the triangle first. So it says that we've got, we're looking at Mount Rushmore. We've got 2 sightings that are both from the 700 feet distance from the base of the mountain. And we have 2 angles of elevation. The first one is going to the bottom of his face, the second one to the top. So if we're standing over here, let's make that our 700 feet. And this is Mount Rushmore. So there's our right angle. So we can use right angle trig, so Katoa. And then we've got to the top of his face as well as to the bottom of his face. And what they told us is the bottom is 32 degrees. And to the top is 37. I'm going to put a little 5-degree measure here because we don't really have a ton of room. And we're trying to find the length of the face. So really just this little itty-bitty distance at the top. Now again, there's multiple ways that we could potentially do this. In this case, what I would probably do is set up 2 tangent functions because we have opposite are all the side lengths over here. And the adjacent would be the 700. So in order to do this, I can't use tangent with x the way that I have it drawn. So I'm going to add in that this length below the face is y, and then the total length is z. So using y and z, I can set up 2, again, tangent functions. So we'd have tangent of 32 degrees equal to opposite over adjacent. And if we set it up with tangent of the 37 degrees, again, we'll have opposite is now the big length over still, again, adjacent 700. And then kind of just thinking forward, what are we going to end up doing to find x? Well, to find x, we'll use a skill back from geometry, segment addition. If we take the longer length z and subtract off y, that's going to give us our full length. So that's what our goal is when we're all said and done. So what I'm going to do is solve each of these trig functions for y and z. So for y, we would type in 700 tangent of 32 degrees. And for z, we'd type in 700 tangent of 37 degrees. And instead of typing those in individually, I'm going to do one big function in my calculator so I can withhold as many decimals as possible, keeping it more exact. So z was 700 tangent of 37 degrees minus y 700 tangent of 32 degrees. And if we type all of that in, we get approximately 90.09 or 0.1. And again, this is in feet. One point to make of this part in our work here, all of the problems that we've been doing thus far have been in degrees. So make sure if you're getting some weird decimals or things aren't matching up on your calculator, perhaps double check that you're in the degree mode versus radians, because we use those back and forth with our different concepts we've learned this far in this semester. So for our last problem, we're finding the area of this quadrilateral. What I've done so far is just draw on the diagonal. And I want to avoid drawing it the opposite way because I don't want to assume that the 30-degree angle or the 110-degree angle are split in half or anything like that. And then I'm just going to label this bottom triangle area 1, and then the top triangle I'm going to label area 2. Now, triangle 1, I have side, angle, side. So in that case, I can go directly to the 1/2 formula that's on your formula sheet. So in this case, we have 1/2 times one of the sides, 40, times the other side, 90, times sine of, in this case, 30 degrees. And again, this becomes calculator work, and it actually is an exact value of 900. And we're working with area, we're in square feet. And then I'm going to put a line here for area 2, but unfortunately with what was given, we don't have enough information to find that area just yet. So what I'm going to go ahead and do now is find some missing pieces. So first, again, I have side angle side in the first triangle, so that means I could find this missing side, the diagonal that I drew in. Let's start there. With side angle side, that's our x squared formula of law of cosines. So I'll write that over here. If I want to find x squared, I'm going to take the two sides that they gave me, 40 squared plus 90 squared. And then I'm going to subtract 2 times 40, put the rest down here, times 90 times the cosine of the angle in between, which is 30 degrees. And as a reference point, if we type that in, this is going to be rounded. We're at approximately 3,464.62. That's just a checkpoint if you want to double check your work. But the value that I'm going to work with for our x is 58.87 after we take the square root there. Now, once I have that in place, still don't have enough information to find the area of triangle 2. I have side angle, which doesn't work with either of our two forms. So at this point, you could potentially work to find the missing side in the triangle and then use your side area formula. I, however, am going to find this angle down here, which I'm going to call angle B. And then I'm going to find the angle up here, which I'm going to call angle C. So then I can eventually find side angle side and use that same formula that I did for the first area. So to find angle B, at this point, I have the 110 degree angle and the side we just found was X. They're across from one another, and the 10 feet is across from the angle I'm trying to find, so I can use the law of sines. So sine of 110 over the X, which was the 58.87 we just found. And then we have sine of this missing angle I'm calling B over the 10 that was given. So if I solve for sine of B, just to get an approximate here if you need it, 0.1596, but really the angle I'm going to work with here is approximately 9.18 degrees. Still don't have side angle side, so I have to find again the angle C that I have marked. So we'll take 180 minus the other two angles that we just found. So angle C is 60 point, I'm going to again carry 2 decimals, 0.82. So now having that, I have angle C and then the two sides around it, the 10 and the 58.87 that we found. So now I can use side angle side. So coming back over here to area of angle, or of triangle rather, 2, I'm going to do 1/2 times 10 times the 58.87 times sine of angle C, which we found to be 60.82 degrees. Then double check your work in your calculator. We're looking at 256.99, again, square feet. And finally, one more step. We just have to find the total area. So add those up. And 1156.99. So again, if you found this a different way, that's your target. Obviously, if you round differently or, truncate some of your values within your calculator as you're working, you're not going to get that exact same value as me, and that's okay. I would say that if you're, within 1 or 2 points of that, you should be perfectly fine. But if you have questions, certainly ask in class.